Alright, so in this example we've got this pretty big polynomial function and we're given one of its roots, the square root of 8. What does that mean? It means that if we were to plug in the square root of 8 into all four of these locations and actually evaluated this whole polynomial function, we would end up with 0. So we're given one of these roots and we need to find all of the other x values that will be roots, all of the other x values, so that when we plug them in here, we get a 0 as f of x. Well, how are we going to do this? Well, here's my claim. If x equals 8 is a root, then it must be the case that x minus the square root of 8 is a factor of our polynomial function, f of x. Why? Well, let's see. I claim that we must be able to write our function now as x minus root 8 times, well, I'm not sure what, but something. And I mean, think about it. If we were to actually go ahead and plug the square root of 8 in there, well, this whole thing would be 0, and it wouldn't matter what we multiply by, because the whole product would be 0. So that confirms that the square root of 8 is indeed a root, and it's definitely a factor. Well, now, there was that theorem that we talked about in class that said, listen, if we ever have an irrational number as one of our roots of a polynomial function, then its conjugate must also be a root. Therefore, I claim that it must be the case that x equals the negative square root of 8 is also a root. This is big. This is big. Because if this is a root, then it must be the case that x plus the square root of 8 is a factor of our polynomial function, f of x. Why, you ask? Well, we need it to be the case that when we plug in negative root 8 into our polynomial, we get a 0 out. So I claim then we can write our polynomial function as, well, x minus root 8, we had that from before, but also x plus root 8, and then times still something. I don't know what this is. I have no idea what this is. If we could figure that out, we'd be well on our way to finding the rest of our roots. Now note, of course, once again, if we were to plug in negative root 8 for x here and here, well, here we'd get 0. And if that factor is 0, then it doesn't matter what else we multiply by, the whole product will be 0. F of x will be 0, and this confirms that negative, the square root of 8, is indeed a root. Okay, so we're already well on our way towards factoring our entire polynomial function. This is pretty cool. Well, how do we find this guy? Well, before we did some polynomial division, but right now, I don't know how I'm going to deal with this. I don't know how I'm going to do any division. But if we were to multiply these two factors together, I think we could rewrite our function as, well, f of x equals x squared minus 8 times something. Still looking for this something, still don't know what it is. Well, geez, we actually can go ahead and divide by x squared minus 8 on both sides of this equation, and it tells us that, well, listen, if we divide our function, that really big polynomial up here, if we divide that guy by x squared minus 8, we should get a quotient, and that will be this missing part of our big function f of x. And if we can find that missing part, maybe we can factor it, maybe we can find the rest of our roots. So let's go ahead and let's carry out that polynomial long division. So here is our big polynomial. We are going to be dividing by, in this case, x squared minus 8. So I say, all right, what must I multiply x squared by to get x to the 4th? I got to multiply by x squared. All right, so check it out. We've already got part of this guy right here. Awesome. And so let's see, x squared times this whole divisor will give us x to the 4th power minus 8x squared. So I'm going to go ahead and subtract these away. I'm going to bring down my 6x cubed. these two guys right here, they are going to sum to, let's see, 17x squared minus negative 8x squared. Oh, okay, so that's going to end up being a positive 25x squared. And I'm going to bring this guy down for good measure, minus 48x. All right, well, I say now how many times is x squared going to 6x cubed? I think 6x times. So plus 6x. All right, I'm going to multiply this guy by our whole divisor, and we end up with 6x cubed, exactly like we hoped, minus 48x. Of course, I'm subtracting this whole quantity, so luckily, right, these both add to 0. That's awesome. Let's bring down this 25x squared business, and we'll also bring down our minus 200. I ask, what must I multiply x squared by to get 25x squared? We've got to multiply by 25. All right, plus 25. All right, so I'm going to subtract, in this case, 25x squared. I multiplied 25 by x squared, and now I'm going to multiply 25 by negative 8, and we get negative 200. This is fantastic because we are going to end up with a remainder of 0, exactly as we suspected. So we found this missing piece right here, this quadratic. That's what goes here, or I mean, more importantly, that's what ends up going up there. So I'm going to kind of take this guy and we're going to rewrite it somewhere where there's a little bit more space. So I claim now we can write our polynomial function as, well, x plus the square root of 8, or did I start with minus? I started with minus. X minus the square root of 8, x plus the square root of 8, and then this remaining x squared plus 6x plus 25. Now note, thematically, oftentimes when we are faced with a problem like this guy will be able to factor nicely. Unfortunately, when I look at it now, it's just not going to factor nicely. So we're going to have to be a little creative here. Now remember, our main goal is we're finding roots. And a root is any x value that's going to make f of x equal to 0. So it's almost like we could take this function's equation that we just wrote down, and it's like we really want to say, well, to find our roots in this case, we're really solving the equation 0 equals that whole same thing that we had before. Well, now here we go. Part of this equation is really easy to solve. Well, here are some of the roots. Well, x could equal the square root of 8. We knew that before. X could equal the negative square root of 8. Right? These two quantities, this quantity for x will make this factor equal to 0, and then the whole thing will be 0. This root will make this factor equal to 0, and makes the whole thing equal to 0. Or this whole polynomial right there must equal 0. And now, all this is now we're just solving this guy by completing the square. So we're going to get some pretty tough stuff. Here we go. I'm going to subtract 25 from both sides of the equation. So we've got an x squared plus 6x equals negative 25. And I see 2/3 of a perfect square trinomial right there. So we're going to have to complete the square. So we've got an x squared plus 6x. And I hope you know what we need to add. We need to add a 9. Of course, that's going to equal negative 25. Of course, what I do to one side of the equation, I must also do to the other. All right, well, here we go. Right here, we've got x plus 3 quantity squared. And that is all equal to, these guys sum up to negative 16. Now we're ready to go ahead and take the square root of both sides. And we end up with x plus 3 equals plus or minus 4i. If we subtract 3, we find that x equals negative 3 plus 4i. X equals negative 3 minus 4i. So check it out. We just found the two remaining roots of this polynomial function. We've got 4 of them. We got one right here, one right here, one right there, and our fourth one right there. We have successfully found all the roots. This was especially tough because we had to solve this equation by completing the square, and it did not factor nicely. So this is great. Now here's the deal. Note that of these 1, 2, 3, 4 roots, 2 of them involve imaginary numbers, and 2 of them are actually real numbers. So note to self, this implies that our graph, the graph of f of x, will have only 2 x-intercepts. And so on the next page, I've got a bunch of graphs, so we're going to have to use this information to our advantage. And note that the square root of 8 is going to be close to 3, a little bit less than 3. Note that these 2 roots down here are not going to show up as x-intercepts on our graph because they have imaginary numbers. And they're obviously not going to show up on our real number lines. Okay, so if we make our way to the next page, we've got 4 candidates that could possibly be the graph of our function. And the first thing we say is, listen, our graph has to have exactly 2 x-intercepts. And so immediately, 2 of these 4 graphs cannot possibly be it. This guy and this guy. Because they have too many x-intercepts. This first one has 1, 2, I think it even has 3, and 4. I mean, it's got more than 2, that much I know. And this guy over here also has at least 1, I think 2, definitely 3, at least 3, no dice, too many x-intercepts. So now we are left between these bottom 2 graphs. Which could it possibly be? And now note, both of these guys actually have the same exact x-intercepts. They are both positive and negative the square root of 8. So how do we tell which one it is? Well, what we got to do is think about the end behavior of this polynomial function. And this is something in our notes that we talked about before. And if I scroll back, I note that our function right here is an x to the 4th, is the highest degree of all of its terms. And that tells me that, you know what? I don't know exactly what this graph looks like, but if we were to sketch its graph on a set of axes, I'm just going to draw a little set of axes down here. If we were to sketch its graph, we know for a fact that it starts like that and ends like that. What it does in the middle here, I don't know, but I know that this is how this graph looks as we make our way towards very large negative x values or very large positive x values. So if we take a look at our next page, oh, you know what? This guy in the bottom right appears to have that exact end behavior that we were talking about, and this graph right here on the left does not, and so we can eliminate it from our competition, if you will, and we say that, you know what? This right here, this guy, this is the graph of f of x equals x to the 4th power plus 6x cubed plus 17x squared minus 48x minus 200. I don't expect us to know exactly what that function looks like, but I expect us to be able to pick it out of maybe 4 possibilities. And so this problem that we just walked through together, this kind of encompassed so many of the skills we've learned in this section, and it will really be helpful when studying for our upcoming quiz. I really hope it helped.